Hi everyone. Today we will learn about decision tree regression. So let's first see what is decision tree. So as you can see, a decision tree is a flowchart like tree structure where each internal node denotes a test on an attribute. Each branch represents an outcome of the test and each leaf node holds a class label. So as you are all familiar with the flowchart, which consists of a root node and several internal nodes, and at the last level there are leaf nodes, and all of these nodes are connected with branches. So in this definition of decision tree, we are saying that all the internal nodes represents the test cases that we apply on our data sets, and the branches that are coming out from these test cases denotes the outcome of the test case, whether the test is passed by a data point or failed. And then the outcome branch comes in a leaf node which represents the label for the data class, for example that this data is belong to class A or class B, etc. Now here, as you can see, the term CART, C-A-R-T, which represents classification trees and regression trees, because decision trees can both be used in classifications and regression. So in this session, we are learning about regression trees. So let's see a example plot of data points which are plotted in x and y axis. So as the plot is given here, now that as you can clearly see that the points are not in a linear relationship, they all are randomly scattered and are non-linearly related to each other. So for this, the decision tree will apply its algorithm and split the data sets into different regions. So let's see how it splits the data sets. So now as you can see, it splits into four types. The first split is at x-axis 20. The second split is at y-axis 170. The third split is at 200, and the fourth split is at 40. So the four splits will form five different regions. Now after splitting, the decision tree will calculate the average of each region, and the average will act as a label for the regions. So let's see a decision tree flowchart. Now as you can see, the root node, the several internal nodes, and the end are the leaf nodes, which represents the average value as the labels. So as you can see that when the suppose x1 at a particular value, if it's less than 20, then the outcome is yes and we goes to the next internal node. If the in this case also, if the outcome is yes, then we get the label 300.5, which belongs to a particular region. So this is the final task done by decision tree by assigning the average value to each regions. So when we predict some values, the average value is calculated, and if the value is near about these average value, then the algorithm will predict that this data point is belong to this particular region. So I hope that the basic concepts of decision tree are clear to you all. Now let's move to the implementation part of the decision tree algorithm. So let's get started with the implementation part. And the first step, as always, we are importing the libraries, and the three libraries are NumPy, Matplotlib, and Pandas. After that, we are importing our dataset, which for which we are using pd.read underscore csv, and the name of our dataset is position underscore salaries. So let's first run these lines of code. Now as you can see, this is our dataset, consists of three columns: positions, level, and salary. In this dataset, we are using level column as our feature of matrix X and salary as our independent variable Y. So let's write these two lines of code. Now as you can see, this is our feature of matrix X, consists of all the 10 levels, and the Y consists of all the salaries associated with the levels. Now after that, we will fit our model, in this algorithm step, I'm not using splitting train or splitting our dataset into train and test case, because our datasets consist of only 10 rows, so there is no meaning of splitting this. And I'm also not using feature scaling, because the library which we are using for our model already transform our columns into featured values, so that's why we don't have to explicitly feature scales our value. That's why I'm directly coming to the step where I'm fitting a model. So for this we are using Scikit-Learn.tree module, and from that module we are importing decision tree regressor class. Now after importing our class, we have to make an object for our class. So we are initializing our object regressor equal to decision tree regressor, and we are passing only one argument, which is random state. Now random state here is the seed value for our randomized number. So if we, and the value for random state can be any integer value. So the main reason of using this random state parameter is that every time we run our code, we get the same randomized value as we get in our previous code. So that's why we are using random state here. Now after that, we are fitting our model. So regressor dot fit the feature of matrix X and the dependent variable Y. So let's run these code. So now our model is trained. Now let's predict a new value, which is 6.5, the value of level which we never trained our model with. So let's run this code and see what we get. Now as you can see, we are getting 1,50,000. Now let's compare it with our data set. So for level 6 we are getting the salary 1,50,000, and here we are predicting for 6.5, so it's very much close. So now let's visualize what we are doing here. So this is our plot. But as you can see that I told you earlier in the basic concepts that the decision tree algo will calculate the average for each interval or region. So here there's supposed to be a horizontal line parallel to our x-axis, but instead of that, all points are joined by a straight line and forming a curve. So this is the wrong plot of decision tree. So to correct it, we are going to use a higher resolution for plotting. So I'm uncommenting these two lines, and you will see the difference after implementing these two lines. So I'm running this whole code once more. Now you can see very well that at each interval there is a same value, because the average will be same for whole interval. So interval 1, interval 2, interval 3, so on, interval 10. So that's all for decision tree. Thank you very much for listening.